Hello and welcome to this quick take video on how to use Xilinx IP delivered in the Vivado design suite with third-party synthesis tools. Here's what you will learn by watching this video. The IP that is delivered in Vivado is only supported using the Vivado synthesis tool. The constraints provided are written and tested only with the Vivado synthesis tool. The majority of the IP deliver RTL that is encrypted and cannot be read using other tools. You will need to use a Vivado Managed IP project or Tel Scripts to create the IP customizations needed for your design. Be sure to generate all output products, including the synthesized design checkpoint. When synthesizing with the third-party synthesis tool, infer a black box for the IP. We provide files to aid in this. When ready, implement the design using the edif netlist produced by the third-party synthesis tool and the XCI files for the Vivado IP. You can either create a Vivado netlist project and add these sources, or create a script to read the sources and run implementation. This training assumes that you are familiar with the third-party synthesis tool you wish to use, how to create IP customizations using Vivado, and how to instantiate them in your design, and finally, how to implement a design using Vivado. We recommend that you watch the following Vivado quick take videos to get the most out of this training: customizing and instantiating IP, and implementing the design. You should review the other Vivado quick take videos, as many other topics are available that may be of interest to you. To start, first determine which IP you need for your design. Once this is known, use the Manage IP project flow to create the IP customizations. For each IP customization, also generate a synthesis design checkpoint. This flow can be scripted as well. You will need 2 files for each IP you customize for use with a third-party synthesis tool. The first is a stub HDL file, which is a module declaration of the IP consisting of just a port list and synthesis directives. Using this will result in a black box being inferred for the IP. When inferring a black box, it is important that no I/O buffers are inserted by the third-party synthesis tool. The directives delivered work with the Synopsys Simplify Pro tool and may need to be modified for other synthesis tools. The second file is the instantiation template for the IP. You will use this to instance the IP into your design. Here we have a Managed IP project open within Vivado where 2 IP customizations have been created and the output products generated. Expanding an IP, we see the various files that are generated. There are 2 files that are needed for use with the third-party synthesis tools. These are the stub and the instantiation file. Opening the instantiation template, you will see where you need to cut and paste to instance the IP into your design. Depending on what your target language is, either a Verilog VEO or a VHDL VHO file is created. Opening the stub file, you will see an empty module declaration along with a synthesis directive to infer a black box and to not insert I/O buffers. A Verilog and a VHDL stub file are created. These files are located in the root directory where the IP was created. Each IP customization is stored in a directory with the same name as the IP. Once all the IP customizations and all the output products are generated, you are almost ready to synthesize your design. First, you need to instantiate all the Xilinx IP you created customizations for into your design using the instantiation templates provided. Next, you need to add the stub modules for each of the IP customizations into your project or script. Now you can synthesize your design using the third-party synthesis tool. After you are happy with the synthesis results, write out an edif netlist for your design. Black boxes will have been inferred for all the Xilinx IP. Now that you have the design synthesized and a netlist produced, you are ready to implement the design using the Vivado design suite. There are 2 main ways to work with Vivado: either using the graphical front end or to write a Tel script. Using the graphical flow, you would start by creating a netlist project. Next, you would add the netlist produced by the third-party tool. Then add all the XCI files for any IP used. Then add your XDC constraints. Finally, you'd launch implementation. When scripting, you can do either a project or a non-project flow script. I will demonstrate the netlist project flow and review a non-project flow script. Here we have a netlist project open with the target part selected. First, we add the edif netlist that was created by the third-party synthesis tool. We go to Add Sources, Add Design Sources, Add Files, navigate to the directory that has the edif, select it, and say OK. Next, let's add the IP files that we created. So let's go to where we have those IPs. Go to the, let's say, the character FIFO. Select the XCI file for one of the IPs. Add an additional file. Browse to the directory of the other IP. And notice each directory is named after the IP. Select the XCI file. Select OK. And then say Finish. Now, let's go and add in top-level constraints for this design. So we'll add files. Browse to wherever you have your constraint files. You can use the Control key to select more than one file, and then press OK, and then press Finish. Expanding this, we can see all the files that were included into our netlist project. Finally, to implement, simply run implementation, or to generate a bit stream, hit the Generate Bitstream. Here is a non-project Tel script, which can be run in batch mode or interactively. First, we set the target part to be used. Next, read the edif produced by the third-party synthesis tool using the read edif command. After that, read in the XCI files for any IP using the read IP command. The IP synthesized netlist and XTC files will be brought in automatically. Next, read in any constraint files that you may have with the read XTC command. Now link the netlist from the third-party tool with the netlist for the IP using the link design command, where you also specify the top-level module name. Now implementation can be performed. Implementation consists of multiple commands. The first of these is the opt-design command, which performs logical optimization on the netlist. Next, you will place the design using the place design command. After placement, you can perform physical synthesis using the physop design command. Once the design is placed, you will route it using the route design command. Next, you should generate a sign-off timing report using the report timing summary command and specify a file name. Finally, generate a bitstream to program a device. There are many options available for the implementation commands. I will provide some references later, which you should review for more details on implementing a design. To summarize, here's what was covered in this quick take video. Xilinx IP delivered by the Vivado Design Suite is supported only by the Vivado Synthesis tool. We provide support for third-party synthesis tools for our IP by providing instantiation templates and stub modules for inferring a black box for the IP. Once you have a design synthesized, you will bring in a netlist along with the XCI files for the Xilinx IP into Vivado for implementation. For additional information, please look at the various instructor-led training courses that might be of use to you listed on the Xilinx website at this location. Some user guides that you might find particularly useful are the Designing with IP User Guide 896, the System Level Design Entry User Guide 895, and the Implementation User Guide 904. Be sure to look at other documentation available using the Xilinx Documentation Navigator software or listed on xilinx.com. Thank you for watching this quick take video on using Xilinx IP with third-party synthesis tools. I hope you found it useful. Goodbye.